We now discuss the solution of a problem from the section Coordinate Geometry. The problem is related to the common focal chord of a given parabola and ellipse. This question has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given problem is, let PQ be a focal chord of the parabola y square is equal to 4x such that it subtends an angle pi by 2 at the point 3, 0. Let the line segment PQ be also a focal chord of the ellipse denoted by E, whose equation is x square by a square plus y square by b square is equal to 1, where a square greater than b square. If E is the eccentricity of the ellipse E, then the value of 1 by E square is equal to, we are given 4 options, option A, option B, option C, option D. We are given a parabola y square is equal to 4x, and it is given PQ is a focal chord for this parabola such that this focal chord PQ subtends an angle pi by 2 at the point 3, 0. It is given that the line segment PQ is also a focal chord of this ellipse E, and if E is the eccentricity of the ellipse, required to find the value of 1 by E square. We now discuss the solution of the problem in detail. We have y square is equal to 4x. What is it? It is a parabola with vertex at the origin and focus denoted by S at 1, 0, opening right. And if you compare the equation of the given parabola with the standard equation of the parabola y square is equal to 4ax, you will get 4a is equal to 4. That will imply a is equal to 1 by a is equal to 1. And the focus of the parabola is S a, 0. A is 1, 0 and opening rightwards. Given PQ is a focal chord of the parabola, the meaning of that, it is a chord passing through the focus, and therefore P and Q will lie on the parabola. It's a focal chord. So the coordinates of P and Q, we take it in parametric form, and the coordinates of P and Q are t square, 2t, right, and 1 by t square, minus 2 by t. Agreed? Agreed. Now, given PQ subtends an angle pi by 2 at the point R with the coordinates 3, 0, PQ subtends an angle pi by 2 at R means PR is perpendicular to QR. A rough figure, you can visualize this one. So PR is perpendicular to QR means the slope of PR must be slope of PR multiplied by the slope of QR must be equal to -1 because PR is perpendicular to QR. The coordinates of P, Q and R are known, therefore the slope of PR can be obtained. So P is t square, 2t, R is 3, 0, the slope is 2t minus 0 by t square minus 3. That is the slope of PR multiplied by, and the slope of QR is minus 2 by t minus 0 by 1 by t square minus 3 multiplied multiply both and is equal to minus 1. Simplify, we get this one, and on further simplification we get this equation. 4t square is equal to minus 3t to the power of 4 plus 10t square minus 3. This will imply t square minus 1 whole square is equal to 0, and it will give you t is equal to plus or minus 1. And if you take t is equal to 1, then it is p, the coordinates of p are 1 comma 2, that of the q is 1 comma minus 2. Even for t is equal to minus 1 also the same one. So the coordinates of p and q are 1 comma 2 and 1 comma minus 2 respectively. And now we go to the next slide and talk about the ellipse and its common focal chord. So the story so far is we have the parabola y square is equal to 4ax and its focus is s at 1 comma 0. And the coordinates of p and q we have obtained as 1 comma 2 and 1 comma minus 2. Now it is given PQ is also a focal chord of the ellipse E, whose equation is x square by a square plus y square by b square is equal to 1, where a square greater than b square. So the PQ is also a focal chord for ellipse, means the foci of the parabola, that is 1 comma 0, is also the foci of the ellipse, and PQ is a focal chord and P and Q will lie on this parabola. So S, whose coordinates are 1 comma 0, is a focus of, is one of the foci of the ellipse, and 1 comma 2 and 1 comma minus 2 lie on E because it's a chord. And if we substitute 1 comma 2 in this parabolas, in this ellipse equation, then you will get 1 by a square plus 1 by 4 by b square, 1 comma 2 is equal to 1. Agreed. And by the by, the center of this ellipse is the origin, and one of the foci is 1 comma 0, therefore the other foci is minus 1 comma 0. Then you can visualize roughly how this ellipse will be. Further, b square is equal to a square multiplied by 1 minus e square, where because a square is greater than b square and e is the eccentricity of the ellipse. And because 1 comma 0 is a focus for e, and the foci of the ellipse are given by plus or minus ae comma 0, therefore ae must be equal to 1. ae comma 0 is equal to 1 comma 0, therefore ae is equal to 1. And in this equation, 1 by a square plus 4 by b square is equal to 1. Substitute b square is equal to a square times 1 minus e square. Then you will get this equation. Now ae is equal to 1 will imply a is equal to 1 by e. That please keep in mind. Now this equation we have taken, multiplied throughout by a square, then we will get 1 plus 4 by 1 minus e square is equal to a square times 1 is a square, and a is equal to 1 by e. So a square is equal to 1 by e square. Now further simplification will give you this equation, and on further simplification you will get this. And finally you get this equation, e to the power of 4 minus 6e square plus 1 is equal to 0, and the answer what is asked is in terms of 1 by e square, therefore divide throughout by e to the power of 4. Then you will get 1 by e to the power of 4 minus 6 by e square plus 1 is equal to 0, and it is a quadratic equation in 1 by e square. So solve for 1 by e square, and that is equal to minus b plus or minus under the square root of b square minus 4ac by 2a, and that will be on simplification you will get 3 plus or minus 2 root 2. 3 plus 2 root 2 is obviously positive. 3 minus 2 root 2 is also positive. So both can be answers for 1 by e square. Let's look at our option and what is the answer that is there in the options. So the option B, that is 3 plus 2 root 2 is there, and that is 1 by e square is equal to 3 plus 2 root 2 is an answer that is given in the options. Therefore, the 1 by e square is equal to 3 plus 2 root 2 because it is given one among the options. Agreed. And the answer to this question is option B. That is the detailed discussion of the solution of the problem from the coordinate geometry. It is the question is based on the concepts of common focal chord for a parabola and an ellipse. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.